So Dr. Sunil Morekar is the visiting professor lecturer.
So we can skip the introduction.
Sir is no very important for.
I will say
sir is the
sirf naam hi kafi hai.
Sirf naam hi kafi hai, bilkul. Absolutely agree. And sir is the reviewer of
so
so many journals.
No introduction. I'll just we'll go to the let the presentation talk.
Absolutely.
Okay. So I thank the organizers. I thank IGO. Definitely a brilliant job, and the chairperson of the instruction course. So whether we want to be another brick in the wall, let me tell you that the whole idea was that if you make a publication, you're not just another brick in the wall in the world. But then some of us have presentations in publications in journals, and those publications are also just another brick in the wall. They are absolutely horrible, this thing, including mine. So there are some papers which I have published, but then I have pulled them out, and at international fora I have told people what is wrong with my presentations. So I will tell you this, your job is to find out my presentations and write to me, this presentation of yours is wrong. Right? So what are the appropriate statistics tools to be used? And the data visualization, yet another brick, you can make it 50%, but you can put in your graphs and other things and make it look like, yes, you are, this is what your visualization is. Here, we understand that statistics is something that is, there is truth, there is falsehood, and then there is statistics. Lies, white lies, and statistics. You can use statistics. You can give me any data. You can give me anything you want to prove. I can potentially prove anything that you want to prove. But that is not how you go about it. You will go about it not out to prove a point, but to figure out, collect data, and then try to come to a point rather than proving your point. So we know that a lot of things happened with COVID and HCQ, and none of them had a Cochrane review or a forest plot, or the study designs were all this thing. And then sometimes we said that HCQ is useful, then we said it's not useful, then we put it in the data, then we pulled it out of study designs. And so many COVID graphs you will see in newspapers, in journals, in reputed journals, which are so misleading. So what is it that you want to know? You want to know what to do in terms of statistics as a tool to find out the truth, not to make somebody believe what you think is the truth. So you are somebody who's inconsequent. Data is data, God, right? So disclosures, financial nil. I do have to say that I am a member of the Cochrane collaboration, and some of the workshops there are paid for, and some of the other things which I'm associated with also have paid workshop. I also work with the Council of Science Editors, where we train editors. So anybody who wants to train himself or herself to become an editor in the future, you can come to us, but these are also paid workshops. This has got nothing to do in terms of financial disclosure. So this is something that we've been working since the last 14 years in different places. So the objectives, there are many objectives. I'm not going to run into it, but broadly you want to identify the type of data and the appropriate test for that data. I'm not going to talk about sample size in detail here, but what inference you get and what are the top Bradford Hill criteria. We say that there is correlation, and people say that this is causative. No, there is a difference between correlation and causation. Causation has to follow the Bradford Hill criteria. So let's begin. You are here, and I'm still here after 15 years. So I am still at the bottom of the graph. I'm still trying to figure out, there are people like Santosh who probably at the peak of the graph, but then I do realize that when I don't understand statistics, that is what I take in my hand and sit. So the broad topics of research which we normally do, we look at the therapy effect. This is what we will do most of the times in our lifetime. Then we look at diagnosis, validity, and reliability. Screening, when you pick up pre-symptomatic cases. So you do a cross-sectional study, and these are the people who out of them is going to develop cancer, who out of them is going to, so you do a cross-section. So you look at one time, point in time. When you're looking at prognosis, what is going to happen in the future, then you have to have a longitudinal cohort. And when you're looking at causation, you'll want a cohort study, 2 cohorts. One is exposed to something, one is not exposed to that thing, or a case control. Now, most of the time people say that RCT is the gold standard, but every test, every design is useful, because you have to understand that we would not know anything about thalidomide if a case paper or a case report was not there. And look at Avastin, innumerable case reports. So 1,400 which forced the FDA to ask for a RCT or a randomized control trial for Avastin versus Lucentis. So case reports are also very important. Each one of these study designs is important. Don't, so you have RCTs, You have parallel group comparisons. There are two groups, each entering the study at the same time, receives different things. Paired, you have one group which is similar, same age, same sex, same kind of thing, and it is paired with the other group. Within subject comparison, you are looking at subject assessed before and after the intervention. So what was me before, what was my blood sugar after. So you're pairing within the subject. They can be single-blinded or double-blinded. Double-blinded is something that you most often want to do, but there are some cases in which you will have to have single-blind. Then you can have crossover. So your one group is getting this treatment, timolol, you wash out period, and then go to dorzolamide. Those are crossover studies. And then you have placebo control. Placebo control not always possible, because if I have glaucoma and you are going to put me in a placebo group and I will develop blindness, you can't put me in a placebo group. So placebo group, not always possible. No? Then you want to look at the tails of a test. So you will see that there can be a movement of the variable. So IOP can only go in the higher direction, or can it go into the lower direction also. Height can only increase, I cannot go down. Weight can increase, can decrease. So there are two tails of a test. When it can either go up or go down, you use two tail test. You cannot use a one tail test for a variable which can go up and down. You can have a factorial design which permits the investigation of effects both separately and combined of more than one independent variable on a given outcome. Cohort studies, when two or more groups are selected on the basis of difference to the exposure. So tobacco, no tobacco, right? Or high-collared shirts, no high-collared shirts, and whether I develop glaucoma, right? So there are two groups, two cohorts, which are similar cohorts, right? And you have case control studies, so you find your case. So many of my things are case control studies. So even when I'm done something like Wolfram, I will compare it with conventional AI, which other people have done. So I will find comparative groups and studies. Cross-sectional, like I told you, representative sample is interviewed, examined, or studied to gain answer to a specific clinical question. And case reports and case series. So now when you look at, everybody tells me you should do an RCT. So there are times when I have received an RCT as an ethics committee. So I right now I'm the co-chairman of the ethics committee at AIOC. So many times I get, I have been with UNESCO for the ethics committee. I get a lot of RCTs. Many times the RCT is unethical. You cannot do an RCT. One of the biggest problems here in India was cervical cancer and vaccine, and they wanted to do an RCT. How can you do an RCT? How can you keep somebody away from a vaccine which can save life? So do you want to do an RCT whether vaccine will save a person from COVID? So you put 100 people with no vaccine, 100 people with vaccine, and put them into a COVID ward. You can't do that. So RCT is not always ethical. RCT is not always possible. So you have to choose your study design. There is a fixation or an obsession with RCT, with many of the judges and many of the senior people like us for years. Even I have been obsessed with RCTs. It's RCT nahi hai. It's prospective nahi hai. So you can do audits and other things like that. So I said this, repeated the slide one more time. Then you have to see whether the study design is sensible. All right, whether specific intervention is considered and what it is compared with, right? So I find out the efficacy of this program with handouts and phone numbers, and then ask people later on. So am I introducing biases? I'm talking into you, मैंने सबको आपको देखा है, मैंने बाहर जाके आपको पूछना है कि आपको program पसंद तो आया ना? All right, yes and no, and everybody will say yes. You're forced to say yes, right? So what outcome measured and how? So field, whether it is for a longer time, I cannot say perimetry is better. What is perimetry after 5 years? What is perimetry after 10 years? So how long has it been measured, right? So these are important things. IOP measured at different times. I compare the IOP in the morning with the IOP in the evening. In the evening, the IOPs are low. In the morning, the IOPs are high. And then you say, no, I got a difference. That's not how you do a paper. So at the end of it, the statistics is important. And whatever statistics you use, I'm going to challenge it in every paper, even my own published papers 5 years later. Right? So study design, again one more time, risks and prognosis, case control and cohort. You don't want to do RCTs there, right? Treatment efficacy, yes, you want to do RCT. Diagnostic test, you do paired comparative, you find out sensitivity and specificity. We come to that, right? 2 surgical procedures, I'm just stressing on this again and again. Randomized control trial, evaluate a diagnostic test, cross-sectional study, prognosis and outcome, longitudinal cohort, and case control. So we need a nil. Is time over? So why do we need a null hypothesis? Null hypothesis is you can't do studies for something which is glaring. Now you look at COVID vaccine and you realize that COVID vaccine I have given to 100 people and 90 people did not get hospitalized. And 100 people did not take it and 90 of them got hospitalized. Do I need a study for this? You need a study to identify the subtle differences between things where you don't know. Something which is glaring, you don't need a study. There are many times I find a study which is something which is not necessary in the first place. The visualization itself was enough. So then you look at what are the variables in the study. Now what are the variables that you're studying? So the variables can be numerical, numbers, or categorical, qualitative, right? So the numbers can be discrete. So these are integers, often counts, which can be progression-free years, overall survival, that way. And they can be continuous. So it is IOP, 17, 18, 19, 20. They can be continuous data, right? Or it can be categorical, which is ordinal, which is ordered. He went from stage 1 of the disease to stage 2 of the disease to stage 3 of the disease in an order. Or it can be nominal, which are not ordered. O plus, O positive, A positive. There's nothing ordered about it, right? But it is categorical, qualitative. There are no numbers involved here. So then the discrete data can be binary, 2 choices, yes or no, dead or alive, disease free or not, or categorical, 2 choices which are not ordered. So in this race you will see more this thing, in African race you will see more glaucoma, or you can have ordinal more than 2 choices, like stages of a cancer, 1, 2, 3, 4, or I have given a questionnaire Likert scale, 1, 2, 5, right? Continuous data can be interval, can be ratios. So keep this in mind, there can be ratios and you can compare ratios as well. So type of data, what is this type of data is important because the type of data will define the summary measures. So you have 2 groups before and you will find out the summary measures and you will do a descriptive statistics comparing before entry whether these 2 groups were different altogether. So if 2 groups were different altogether, this was an older population, this was a younger population, and these people died after the intervention, these people did not die. They didn't die because of the intervention, they died because of the difference between the 2 groups. Many of the papers and many of the things that I get, they don't have descriptive statistics at all. So where is your descriptive statistics? Did you compare those 2 groups before you did the test and find out whether the p-value is significant or not? And this data and the type of data will also tell you what are the tests you will use. So the wrong test used for the wrong type of data, I'm going to point that out, right? So this is data which is mean, median and mode all in the same place. Median, mode, almost the same, right? And this is a very symmetrical graph. So this is what you call as a normal data or a parametric data where parametric tests are applied. This one is skewed. So your mean is there, the median is down. These points, many of them are below this thing, a couple of them are above. So this is a skewed data. This is non-parametric. You cannot apply parametric tests here. I'll come to that. So data A, normally distributed? Yes, normally distributed. Mean, median, mode, all are equal. And like 64, 68% lie here, so on either side. These are distortions or skews towards the right or skews towards the left. Positive skew or negative skew. Sometimes you may have a normally distributed looking data, but there is a peak. All the, so what is the mean IOP in most of the patients? 18, 18, 18, 18, 18, 18, 18, 18, 21, 18, 18, 18, 18, 18, 14. So this is a positive kurtosis. You don't want to have this kind of a thing. There's nothing you're trying to prove that, right? So again, the design is appropriate according to the data. Now you find the data and you find out whether you are applying the right, what is the data you acquired and what is the test design you thought of. Then you look at the statistical data, parametric data, continuous. When there is continuous and normally distributed, you will use parametric tests. Non-parametric, continuous data, not normally distributed, or categorical or ordinal data. So when there is categorical or ordinal data, you will use the non-parametric test. When there are 2 samples, students T is used, right? There are 2 samples, all right? Mean IOP before, mean IOP after, all right? Or mean IOP in this group versus mean IOP in this group, all right? But when it is paired, so mean IOP before the drug, mean IOP after the drug, in the same individual, before, after, there is a pairing. Then you will use the paired t-test, right? So I see paired t-test used for data which is not paired, wrong. Or I see a t-test for data which is paired, wrong, right? So it's very sensible. And then my own study, now you have to find this from literature and Google it out and find out with my name associated in it. There is data which is endothelial cell count before, endothelial cell count on day 1, endothelial cell count on day 2, endothelial cell count on day 30, on 3 months. And I have used PET-T, 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 PET-T 6 times. So PET-T between 0 and 1, PET-T between 0 and 30, PET-T between 1 and 30. So what am I trying to prove? Totally lost, confused. That too when me was into statistics for 5 years. So you see a variation of the data, IOP going up and down, or CCT or endothelial cell count going down or going up. There are multiple data. You will use an analysis of variance, how much variance is taking place. So you'll use analysis of variance, that is ANOVA. So simple thing to remember. So you have multiple data of the same person, multiple data of the same group, multiple data at different times, you will use a ANOVA. All right, don't use a paired T. So when there are non-parametric, which is not normal or ordinal or something like that, you will use chi-square test or Fisher's exact. And for ordinal values, you will use Mann-Whitney U or Kruskal-Wallis. And testing ordinal paired data, you will use a sign test. So pair is a sign. It's a good sign. Pair, couple are, right? So paired sign test and Wilkinson's rank sum test. All right. Now you have to use non-parametric data. You want to see whether the p-value is significant. Now you can, I will not run into the details, but a Pearson's chi-square test is used to compare observed proportions. This proportion of people in this group or that proportion of people in that group. You want to compare the proportions. All right. And nominal data, better or worse, dead or alive, right? And often graphically represented as a 2 by 2 table. Non-parametric of Wilkinson's ranks, again repeating the same thing. This is again the same thing, so I'm not going to do that. So in short, you want to take one picture of this presentation. This is the picture you want to take. There is numerical data. There are two groups. You use unpaired T. There are more than two groups. You will use ANOVA. If it is paired, you will use the paired T. All right. If it is otherwise, it is non-parametric and numerical data, you will use the Mann-Whitney or the Kruskal-Wallis. All right. If it is categorical data, two groups, chi-square test, Fisher's test. If it is more than two groups, chi-square. All right. So this is what you will do. And if this is what is being followed in your paper, I'm going to put this and take this and look at your paper and realize that this is what it is. So what is the data? Is the data parametric? Is the data paired? Is the data over multiple times? Is the test upright? Appropriate. All right. And then these are some examples. We will do this in the panel discussion if there's time. So I'm just going to run. So suddenly an RCT comparing mean IOP following anti-glaucoma drugs in two groups by the Friedman test. Is this correct? Incorrect? Suspicious? What do you think? Suddenly from somewhere somebody has used a Friedman test because he used tests to find out कौन से test से positive आएगा और उस test को लगा दिया. So this is very suspicious. All right, that why did somebody suddenly come out with a test which is not normally used by many people, and suddenly he used this, and you ask them for the data and say, I will apply the test and find out, right? And so again, seeing the same thing, independent samples, parametric, paired T, non-parametric. If it is paired samples, ANOVA, chi-square test if it proportions, McNemar's test if it is compared from proportions from paired samples, and compare two continuous variables, you will do the Pearson's coefficient. And non-parametric, you will use a Spearman. All right. So non-parametric is skewed है इधर उधर भाग रहा है तो spear लेके मारने का. All right. So remember it that way. So if it is non-parametric and you are using two continuous variable, इधर उधर continuously भाग रहा है तो Spearman's test, Spearman's coefficient. Right. So this is how you remember. Now I'm not going to go again to the this thing. You cannot do subgroup analysis. मैं जब तक मेरे को difference नहीं मिलता ना. Okay. Let me look at 30 years old. Let me look at 30.5 years old. हाँ, दोनों में difference मिला. हाँ, so my drug works in people who are 30.5 year old between two groups. So I can't do that kind of a subgroup analysis, right? So we'll run across. So sometimes you see confidence intervals, and confidence intervals when they are very large and wide, then that sample is very small or there is a lack of precision. So confidence intervals is what I'm going to look at. You give me a confidence interval, I'm going to look at that. So again repeating, I'll run through that. These examples I'm not going to talk about, but I'm going to the next this thing, which is your sensitivity and specificity, diagnostic test, RT-PCR, your RAT test, your HRT, your DCT, or something that you're going to use. So you have a 2 by 2 table. There is a disease. So there is no disease and it is not rejected. Specificity. If there is no disease and it is rejected, that is false positive. If there is disease and it is not rejected, that is type 2 error. If there is disease and rejected, this is right, sensitivity, right? So this is what we call, so again I'll explain this. Patients without disease on that side, with disease, blood sugar le lo, ya IOP le lo, IOP higher on this side, that is on the lower on the other side. So IOP without disease and IOP with disease बहुत ज़्यादा है. Then you call these positive, you call them negative. This is true positive, because if you see the parametric, the Bell's curve, the end of the Bell's curve is something which is positive. Though it is positive, it is actually probable to be normal also. So these are false positives. This is true negatives. This is false negative. And then you can have a move towards the right or left, and you get what is called as ROC curves. These ROC curves tell you whether it is a good test, whether the curve is like that. The curve is flatter, it is a poor test. These are best test, these are worst test. Then you look at correlation, X and Y, whether you can correlate and you find a single line. And the correlation can tell you whether that relationship is associated, not causative, right? So you have a correlation. Then you have regression when you're using multiple data points and you're using multiple age के साथ correlation है कि नहीं, इसके साथ correlation है, drug के साथ correlation. So multiple, then you do regression. So you do multiple regression analysis, which is much more useful. And you can have linear, probabilistic, Poisson regression. I'm not going to go into that. And then last is survival analysis. When your survival analysis is evaluation from time to an event, that is death or recurrence or recovery. Drug चालू किया कितने दिन के बाद, कैंसर था कितने दिन तक सर्वाइव कर गया, right? So this provides the commonest example is Kaplan-Meier. Okay, so you have remission in group 1 and remission in group 2. So you want to compare these two. I mean, obviously this is looking, when the data is like this, it looks very nice and you don't need a good amount of statistical this thing, but this is visualization. But when you look at, is there a difference between the two survival groups? Two groups, Mantel-Hansel test or log rank test. More than two groups, log rank test and Mantel-Cox, all right? So finally, you look at Bradford-Hill criteria. So it is strength, consistency, specificity, temporality, biological gradient, plausibility, coherence, experiment and analogy. So when you say that, sir, आपने वो दवा दिया था ना, उसके बाद मेरा आँख गया. So the patient is talking about temporality. You tell him, भैया Bradford-Hill criteria apply करेंगे. Plausible explanation है ही नहीं. Temporality है, आप right है, strength है. Sir, ज़्यादा गोली खाया तो ज़्यादा उल्टी होता है. 4 गोली खाया ज़्यादा 4 बार उल्टी हो गया. Okay, strength है, temporality है, लेकिन बाकी. So many times people tell me that, Sunil, this is how it is. I'm like, no, it does not fulfill. So you will see this in my Facebook post also. Bradford-Hill criteria not. So I will use this. I will use statements even in social media. So the last word, if you think my presentation was just average, it's quite all right. You're just being mean. Right? So read the signs. And thank you for coming early morning. Thank you for keeping awake. Thank you for listening. Thank you for laughing, which means you probably understood something.
And thank you, sir, for explaining things so clearly. So I next invite